Have with us, it's a joint session taken by two professors from Department of Civil Engineering, IIT Madras. So Professor Nikhil, yes, can you hear me? And Dr. Surender Singh.
Yes, Sureka ma'am, we
Yes.
can hear you.
Yes.
Professor Sai.
Yeah.
Hello, ma'am. Can you hear me?
Yes, yes.
Thank you.
Yeah, I can hear you. So I'll just introduce you both to the participants, and then we can have the formal session. So Dr. Surender Singh is an assistant professor in Department of Civil Engineering, IIT Madras. He has a specialization in transport engineering from IIT Madras only. He completed his PhD at IIT Roorkee in 2018, where he worked extensively on the valorization of reclaimed asphalt pavement for cement concrete pavement application. His dissertation on RAP has received a prestigious Indian National Academy of Engineering Innovative Project National Award in 2019. He has obtained his bachelor's in civil engineering from State Government College D. Kras in Murthal in India in 2013 and went to pursue MTech in transportation engineering at the National Institute of Technology, Kurukshetra. His master's dissertation topic was related to the design of cement concrete pavements, the findings of which also has earned the prestigious Indian Roads Congress Bihar PWD National Medal in 2017. Presently he's working on different aspects of concrete pavements, and in total he has published more than 25 dedicated scientific articles on sustainable cement concrete mixes in various international journals. Besides, he is also an executive board member in ICI Chennai and is currently serving as a guest associate editor for the International Journal of Frontiers in the Built Environment. Currently, he is a member of the International Union of Laboratories and Experts in Construction Materials, Systems and Structures, and the first ever Youth Council representing South Asian countries, and also holding the vice chair position for the same. So welcome you, sir, to this session. And Professor Nikhil Bugalia is also an assistant professor at the Building Technology and Construction Management Division under the Civil Engineering Department of IIT Madras. He graduated in civil engineering in 2013 from IIT Kanpur and had subsequently joined Fractal Analytics as a senior business analyst. Post 2 years, he joined the University of Tokyo in Japan in 2015 to commence his master's research in civil engineering. His research examined the performance of reinforced concrete beams under long-term sustained loads. On completion in 2017, he started his doctoral research focusing on the safety management of the Japanese high-speed rail in the University of Tokyo. His doctoral research led to the development of a novel system dynamics-based simulation model for guiding organizational policy for improving near-miss reporting behavior of employees. Additionally, he identified a novel accident mechanism at organizational and regulatory level for the railways. And his collaborative research project had led to association with ADB, Institute Tokyo, Bill and Melinda Gates Foundation, and East Japan Railway Company. His teaching engagements span across various universities, and he currently serves as secretary to the Special Interest Group on High-Speed Rail Policy Investments and Impacts for World Conference on Transport Research Society. With his latest position at IIT Madras, he is developing further on his research interests such as safety management for railways and construction sectors in India, as well as on broader areas of operations management of infrastructure projects. So we welcome both of you to SPA Bhopal and to this particular session of the workshop. Over to you.
Thank you, Thank you. I think Professor Nikhil, can you please share your screen? Yeah. Okay. Okay. Very good evening, good afternoon, and good morning. As ma'am already introduced us, I'm Surender Singh, an assistant professor in the Department of Civil Engineering at IIT Madras. And I, along with my fellow colleague, Professor Nikhil Bugalia, will be just highlighting the activities that we are currently doing to achieve, or we can say to contribute towards the goals of the circular economy. So basically, we are working on how to reduce the carbon and then innovate the technologies for the lean construction practices. So as we all know, this waste, there could be different varieties of the waste in India and abroad also, like construction and demolition waste, agricultural waste, we have the industrial waste. And then this is not a small issue. It's a big issue which need to be looked from different angles, from different glasses. So because of which we wrote one proposal, and then under the Institute of Eminence scheme, we got this Center of Excellence. So we hope in the next couple of years, it will be a full-fledged center in which we'll be developing the technologies for low carbon and lean construction. And also today, one of our agenda of coming here is to get the opinion and the feedback, because we are following different approaches. So maybe whether we are on the right track or it need to be strengthened. So please feel free to give your opinion and the feedback. Next slide, Professor Nikhil. Yes. So as I mentioned, construction waste is a big problem, and then which will be further, you know, hand, increased by the addition of agricultural and industrial waste. So it's not a small issue. It's not the material issue. If we want to definitely contribute towards the circular economy, it needs to be looked from different glasses. So we have the expertise. We have the experts in our group having the expertise in the construction materials, construction management, and building sciences also. Okay, next. So through our surveys and then many other things, what we found that field engineers, or we can say the other industries, they earlier they used to think that is it is big issue, is CND waste is a big issue in India, because we don't have the exact quantity of how much of the CND waste is being generated. Although we have the reports, government reports is also available, but there is a huge fluctuation. Let's say, for example, in 2016, we found that around 700 million tons of CND waste is generated in India. Some publication says around 100 million tons, but on an average, we are at par with the US in generating the CND waste. Similarly, we are speeding up in overtaking China in this aspect also. So, but yeah, it's a we should not be calling it as a waste, but yeah, it could be used as a resource. Why I said this thing? Because there is a big mismatch. If you can see in the table, this is the demand and the reservoir that is available for manufacturing concrete. So as you all knows how to make a concrete, we basically need three materials apart from the water. That is sand, which usually we get from rivers. We need stones, and we need again limestone for manufacturing cement, because cement is the most expensive, and then it leads to a lot of greenhouse gases emission. So these are the things that are needed. So per annum, we need around 750 million tons of sand. But how much is available? Because if you are taking the sand out of the river, it will be affecting the ecosystem, right? So considering that there is a ban in most part of the country on river sand, so from for construction activities, from where should we get the sand? So one of the approaches that we are thinking is that when we produce these aggregates or stones, we have to crush the mountains, we have to blast the mountains, right? So from that, a lot of dust is being generated. Can we use this waste as a sand for concrete manufacturing? Because we have abundant supply of these stones right now. But if I talk about the limestone that is used for manufacturing the cement, per annum requirement is 320 million tons, and we have a good reservoir available, around 90 billion tons available. But please note that mostly that reservoir is under the forest, where we cannot do the mining. So considering the rate of production of cement and rate of consumption of cement to be constant in the next 30 to 40 years, will not be having the limestone to be used for making the cement. So from where the future generation will be using it. And remember, I have said that I'm considering the rate of production and consumption to be constant, but we know urbanization rate is increasing. Right, in next 30 to 40 years, we have to construct more houses. We have to connect more cities with the highways. So on the one hand, we have a significant quantity of the CND waste. On the other hand, we are deficient of the natural materials. So we are thinking how to use the CND waste or the any other agriculture waste to reduce the consumption of natural aggregates, so that to some extent we'll be able to achieve the goals of sustainability. Professor Nikhil, next slide. Yeah. So keeping that thing in mind, because it's a big issue, it's not the material issue. We need to manage it. We need to make the policies. We need to make some strategies on how to use it, right? So considering that we have kept our vision is to become the primary destination in India for all interested in developing and implementing ideas on low carbon lean construction technologies. And in order to achieve this vision, we have framed our mission. Our mission is to develop India's first integrated test bed for evaluating the uses of agricultural, industrial, and construction demolition waste in concrete for directing practices, policies, and standards for waste reduction in Indian construction industry. So we are hoping at least we'll be able to contribute towards the sustainable development. Like our approaches should be socially, it should be contribute towards the economic growth. It should also reduce the negative impact on the environment. So the idea is that we have framed our three ideas to achieve to this mission. Is that reduce the waste that is generated in India? Okay, so we know like India is the biggest producer of rice, right? And a lot of rice husk is generated. Similarly, in north, if I talk about the northern part of the country, we have sugar canes, right? And after extracting the juice, we got bagasse. So, and then mostly we are burning it, and then the ash is being dumped. What we are seeing that these bagasse and the rice, it has some cementitious property. That means they can replace cement for construction of the infrastructure. Similarly, a biggest part of the concrete is aggregates. So we are looking whether we can use this CND waste. Can we acquire the aggregates from it and replace the natural aggregate? So on the one hand, we'll be reducing this waste, also reducing the consumption of natural aggregates for concrete manufacturing. Also, a lot of waste is being generated during the construction stage or during the, in fact, during the planning stage also, a lot of waste is being generated. Like you can see in the picture next, this picture, defects, inventory during making the concrete. When we over process it, it's again a waste. When we over produce it, we have to dump it. And during the transportation also. That means we have to work on encouraging the lean construction practices. So sustainability in our terms is not only reduce the waste, but reduce the natural aggregates demand and also reduce the waste that will be generated in the construction process. And nutshell, we can say we are trying to approach the sustainability goal through this center. Okay, next slide. Yeah. So if I talk about the impact, so if I'm not talking about the agricultural waste or the industrial waste. This we did a small analysis on the CND waste, that is construction and demolition waste. If you are able to use 1 ton of the CND waste that is dumped in the open fields or illegally dumped, if you are able to use it for construction, it can reduce around 6.41 kg CO2 equivalent. It can reduce the saving of around 19 million joules because it will be reducing the consumption of aggregates for concrete construction, and also that landfill that we were using for CND waste, that land could be used for other activities. So what we want to do, we want to convert this waste to resource. We want to innovate some technologies will be sustainable in the nature. We want to come out with some of the techniques, the strategies on how to coordinate, how to monitor, and how to suitably use this waste. And in nutshell, we have to make some framework and policies. And then we have Professor Nikhil, who will be discussing on the approaches that we are intending to follow to achieve the mission as well as the vision. Professor Nikhil, over to you.
Thank you, Dr. Surender, for that good overview. So, as highlighted by Professor Surender's presentation, it is a wicked problem, right? You can easily see that on the one hand, there is a waste, high amount of waste being generated. On the other hand, there is a natural resources which are still not being utilized to their best of use. As well see, we also see that there's a good impact, even if we try to reduce CND waste, if we just focus on construction demolition waste, we can achieve a lot of socio-economic and environmental benefits. Still, the problem is not anywhere near to the solving. And this is a classical example of a wicked problem, which basically is governed by interactions of so many different players, so many different stakeholders. And therefore, it often requires a multi-pronged approach. You cannot have just one solution and go ahead with it. You need to tackle these problems from a multiple aspects. So this is where, let me briefly provide you an understanding of how we are tackling. And as was briefly introduced also by Dr. Surender, at the base of this multi-pronged approach is definitely the fundamental scientific questions that we all have, where that is to assess the suitability of different types of waste for having a sustainable construction, because construction functionality should also be achieved. right? And we aim to address some of these questions through a lot of analytical, experimental, and empirical approaches. But we do not want to stop just at the scientific research outcomes. We want to convert the outcomes of our research into technologies that practitioners can actually use, maybe readily available in the market as well. So we hope to enable a lab to market transition for all our ideas, all our work that is actually coming out of our scientific research. But at the same time, we all have seen that technology development is not something new. There are thousands of technologies for solving a particular problem that gets developed each year. But still, a lot of these technologies never get adopted in the organization. And this is where we understand that in order for these technologies to get adopted, the management of various organizations also need to commit to these technologies, and the business as usual is not going to work. So we also plan to work with a lot of companies in civil and infrastructure sector in an applied manner where we can achieve the adoption of these technologies in the real world. But again, we are not limited to changing up one particular organization or changing only a handful of organizations. If we really want to achieve the changes at scale, we need to promote or at least target towards industry-wide changes. And that is where we are also focusing on policy-related research, where we will be demonstrating the initial momentum, not only to some sort of a successful case study, but we also want to advocate policy-level changes which are related for low carbon and lean construction. So in total, you can see there are multiple facets that we need to address in order to solve the problem of lean sustainable construction. And these are related to the scientific research, the technology development, the applied research, and the policy research. And at the center of all these facets is the essential concept that we call as a systems thinking approach. And I'll elaborate on this systems thinking concept in the next set of slides. So as you might all have seen this particular circular economy for construction in some form or the other. We also fundamentally believe that addressing all the elements of this particular circular economy that is available on your screen is necessary in order to tackle the challenges that we have just elaborated upon. So definitely the sustainable construction begins with selecting sustainable materials in the top. But we also need to design the construction processes in a minimalistic manner. We need to construct as efficiently as possible and as durably as possible so that we avoid repeated retrofit and avoid waste generation. We should also, once the structure reaches its durable life, we should also be able to smoothly dismantle these structures and recycle and reuse the material as much as possible. So this whole diagram is often known as the cradle to cradle approach, and it is essential that we focus on all of these elements simultaneously rather than working on just silos of individual of these aspects. At the same time, we also have to look for the interlinkages between a lot of these elements. For example, when we talk about the recycled materials, it is not only sufficient to know whether the material, a particular recycled material is actually going to be useful in concrete development, but we also should know what are the socio-economic and environmental impacts of supply chain of these materials, whether recycling will actually promote lesser carbon reduction or more economic from a life cycle perspective. So this is where we really need to understand the interlinkages between all of these aspects of this. And this is what we call also as a systems thinking, where you cannot focus only on an individual element, but as a system as a whole. So let me further elaborate some of these concepts and some of the individual projects that we have as part of this holistic approach that I just explained. So to begin with, a lot of scientific research in our center has to focus on recycling a variety of construction materials, right? So Dr. Surender was giving some example of not only C&D waste, but agro waste, and also waste from several other industries is a bigger problem. And we at IIT Madras are indeed the leading group of material research in India, and we wish to leverage our strength to develop what we call as an integrated test bed, which will be the first of its kind test bed in India. And the idea behind this integrated test bed is that it is a facility for our industry partners to be able to come with a waste material. Then we will be able to process these materials, sort this material through some mechanical, chemical, and digital means and turn them into an engineered product which can be readily used by our industry partners. And in this process, we will also be able to get an understanding of what is the technical, economic, and environmental feasibility of using a lot of these waste material in construction. And so this will be the first of its bed in India. And a lot of these technical details I can go in the question and answer section about what are the specific tools and technology that we are aiming to develop as part of the integrated test bed. That was from a scientific research perspective. But from an applied research perspective also, our group has long been advocating the use of digitalization and automation in achieving efficiency for the construction process and achieving the goal of the low carbon and lean construction. And in fact, we were the first one group in India to advocate use of tools such as building information modeling to reduce waste and help industry achieve sustainability. Although unfortunately, even after 20 years of advocacy, the change in the industry-wide has been slow. And that is the challenge. That is the challenge that we have to address, and we'll continue to do that, continue to engage with the industry in order to really provide them ideas how to modify their processes so that the adoption of these digital and automation tools could actually be enhanced. Currently, we are also leading country's revolution in digital construction in form of a 3D printing. And in fact, India's first 3D printed house is in our campus. And I invite all of you here to come visit our campus and visit this facility, which is a wonderful construction. And it was recently inaugurated by our Honorable Vice President of our country. And here also we have worked very closely with the industry partners, the technology provider and startups, which we think are an essential element of the entire ecosystem in order to leverage the technology from the lab scale to the market scale that is we're talking about. And so this is the direction that we have all long taken, and we plan to continue to develop this applied research further with industry stakeholders to promote adoption of digital and automation approaches for construction and achieving sustainable, lean, and low carbon built environment. Last but not the least, capacity building and policy is also a critical aspect which is often neglected, especially when engineers are involved in the work, because we tend to avoid that political related work. But this is where we are stepping our game, and we really think that as engineers, we should also lead the policy development in this country. And in order to really materialize the industry-wide change, this has to be part of our overall agenda. So on the one hand, we aim to develop case studies for low carbon and lean construction, and maybe develop teaching material for tomorrow that we can use to train the new cohort of construction engineers who will be then well aware of sustainable construction. But that's not all. Capacity building does not only is limited to students, but we also plan to work with government organizations, professional bodies, and the stakeholders who are actually involved in developing a lot of the building standards that are used in our country currently. And once we are able to reach to them, we have an opportunity to create a much more opportunity for all other industry partners to also adopt, because things once they have been set in standards, it means there's a lot of ecosystem that gets created around the area, and the material can be readily used, right? So this is, but at the same time, for policymakers, we also are aiming to develop such tools where, for example, the decision makers or the policymakers could look at our dashboards and track the flow of waste material at a city level, so that they can actually plan the efficient use of materials, not at a particular site, but as far as the city level, and the resources can be shared, maybe different sites across within a city, or maybe even different cities of India, because not all cities will be generating same amount of waste, and not all cities will be having same amount of demand for the construction resources as moving along, right? Depending upon lots of factors, these might vary. So, but at the same time here, we also recognize that governments are not working in isolation, and policies do not work in isolation. They have to be practically rooted. And this is where we also think that leveraging the public-private partnership is essential, where our group has been advocating research on promoting frameworks for successful public-private partnership for public infrastructure projects in India. And this is what we aim to continue in order to also for the sustainable and lean construction that we are talking about today. So in and all, this was the circular economy and the systems thinking concept that we have we think that is a way to address the problem of lean construction and low carbon construction that we are talking about. However, this is not all, and one of our purpose for us to be here today is invite all the stakeholders who are also listening this conversation right now, or maybe some of the other people who are interested in the topic, to really come engage with the dialogue with us and really help us to improve our approaches, contribute through bringing their ideas, their skill set, and together only we can actually achieve the dream that we have set up here. So we are actually already planning a lot of international engagement. IITM is very well connected with a lot of research groups. And this is not a problem only in India. A lot of research groups in Europe, United States, Australia, they are also tackling this problem. So we are continuously exchanging ideas with them, learning from them, and sharing our lessons with them, so that together as a world, we can move to a better sustainable world in the future. And specific engagement opportunities, we are right now having an open opportunity for postdoctoral research. So if any of you is interested in any of these topics that we just discussed, you can go on our website and apply for the postdoc opportunity. And in addition, we are also happy to introduce you the international workshop in advances in technologies for lean and construction and low carbon that we are organizing in 10th of 11th December. So we hope that we will see a lot of you through our continuous engagement, and please feel free to contact us, any of us who are involved in this project, and we look forward to being in touch with you. Thank you so much. Thank you, SPA, for providing us with this opportunity. And it's a really timely program that you have organized, and I look forward to presentation of other speakers as well. Thank you.